Hey physics friends, Mr. Collier here. Today we are going to wrap up this chapter where we're talking about forces by talking about a very important force, friction. What is friction? So the sort of physics definition is that it's a force that resists motion, and a key word here is that friction is a force. So we're going to treat it like we've been treating our forces, which means they have magnitude, unit, and direction. They are clear as mud. They are vectors. Specifically, friction is a force that's created when two materials or two media, right, are in contact with each other. So it takes two to tango. You need two things touching in some way to create friction. So one way to examine friction is by thinking about it as the uneven surfaces of touching objects as they rub together. There's a little more to it than that when we're talking about some of the different types of friction, but this is pretty easy to sort of see. And it requires energy for these surfaces to be in contact, and this is why things that experience a lot of friction tend to warm up because of the energy. So things that are experiencing a lot of friction get hot. And these forces, this force of friction, is going to affect the motion of objects. So friction is going to slow things down and change how they move. We're going to investigate that in more detail in this chapter. So we did a little mini lab in class to see what factors affected friction, and now we're going to spell those out for you here. There's two main factors that we're most concerned with when looking at what is affecting the amount of friction there are between the two surfaces. The first is, what are the surfaces? What's the nature of them? What the two things are made of affect how strong friction will be. We kind of distill this into a single measurement that we call mu, pronounced mu, and written as kind of a little cursive looking U. It's actually a Greek letter, mu, and that is going to represent the coefficient of friction. That's basically telling you how rough or how smooth the two surfaces are. The second important thing for determining the strength of friction is the normal force. If you can picture how much friction, how much grip there's going to be between two surfaces, it depends on how hard they are pressed together and what they are made of. And I think that makes a lot of sense. So the normal force is going to be represented with an N, or sometimes an F sub N, is how hard the surfaces are pressed together, and mu is what those surfaces are made of. There is a third factor, and that is the relative speed of the two objects. Friction will change at higher speed, but we are not really going to get into that in this course, but just something to consider. So knowing what contributes to friction, let's look at a few just quick examples of things that have friction. So tires on the road. It's important that your tires have friction because that's what keeps you on the road. And the energy exchange that takes place is why your tires get worn out. But that grip is important. And depending on the road conditions, you might want more or less grip. And so that's why you'll see different cars with different tires. Also related to your car, your brakes are going to wear out over time because of that constant friction, that rubbing. But the friction is important because that's what slows you down. Sledding down a hill, whether you go fast or slow, your shoes for different occasions, a big piece of the bottom of a shoe is how much friction it creates and what you want. We're going to be studying three different types of friction. The first is called static friction. Static in this case means without motion, and that's exactly what it is. Static friction is the frictional force just before motion between the two objects begin. This is like the amount of friction that you have to overcome to get an object in motion. And this is going to be abbreviated with, again, that mu with a subscript s to represent static friction. The second type of friction is called kinetic friction, or sliding friction. This is the frictional force that takes place when objects are sliding past each other. It's important to notice that even if you have the same two objects in contact with each other, like your shoe against the ground, the static friction coefficient is going to be different than the kinetic coefficient for that exact same objects. And then there's rolling friction, which is when something is not sliding or slipping, it's rolling. And there's some more complicated math that's going to be involved there that we're not really going to get into. One last thing, it's worth noting that this static friction is usually higher than the kinetic friction, and so you tend to see higher coefficients there and higher total values. All right, so let's lay out some important principles in understanding friction. The first is that it's going to act parallel to the surfaces that are in contact, and the direction of that friction is going to be opposite of the direction of motion, or in the intended motion, right? In the case of static friction, the object's not actually moving yet. So let's draw a diagram so that you can picture these two concepts a little better. So here is an object. It's got a normal force acting on it. You push it to the right, and we want to understand how it's going to move. Well, there's going to be a force that holds the surfaces together, or the weight of the object, and which direction is friction going to be? So it's going to be parallel to the surfaces that are in contact and opposite the direction of the applied force. So that is going to look like this. Again, parallel to the surfaces, so it's this way, and opposite of the applied force, so my arrowhead goes that direction. And that's how you're going to find friction. We can also analyze friction mathematically, and we're going to get a couple equations here. They're really the same equation, just written with different subscripts. So when we're looking at static friction, the maximum amount of static friction that an object could have is equal to the mu of static friction times the normal force between the two objects, and that's going to be the amount of force that you need to overcome to get it into motion. So you'll see we'll do some word problems, and I'll do some sample problems probably in another video, but if you know the static friction between the two objects, I should say the coefficient of static friction, and you know how heavy each object is and therefore the normal force between them, you can calculate the static friction. And then the same thing is actually true of the kinetic friction. It is also equal to the coefficient, but now of kinetic friction times the normal force. The static friction does tend to be greater, so when you're pushing on an object that's not moved, you're going to be looking at the static friction equation, and then you have to overcome that. Once it starts moving, you're going to switch to the kinetic friction. So you might do some word problems where you actually need to use both of these equations to consider the object at different points during its motion. One last thing, there is a chart of friction coefficients. This number can be calculated, but on other questions you'll know the materials and simply want to look up the mu. If you want to do that, it's on page 124. It's got some common materials that might be in contact and their frictional coefficients listed there. So that's it for friction. Good luck. See me with questions.